Okay. Right, so today we're going to talk about solutions and concentration questions. Okay, so what is concentration? Concentration is the number of particles in 1 decimeter cubed. So its unit is moles per decimeter cubed. And it tells us how many particles are in 1 decimeter cubed. Now, 1 decimeter cubed is, and remember we're talking about solutions here, so it's 10 centimeters by 10 centimeters by 10 centimeters. It is 1,000 centimeters cubed is equal to 1 decimeter cubed. And usually we're talking about aqueous solutions, so it is the number of particles we have in 1 decimeter cubed of water. So we have so many particles in 1 decimeter cubed of water, and we need to use the equation concentration is equal to moles divided by, moles divided by decimeters cubed, or N in moles divided by volume in decimeters cubed. So by remembering the unit, it is quite easy to remember the equation, because for concentration it is just literally you take the moles and you divide by decimeters cubed. That is the concentration. So a concentrated solution, so this would be an example of a concentrated solution. Now the opposite of concentrated is of course dilute. Now if we were to have a dilute solution, so dilute, we would have fewer particles. There would be less dissolved in the same volume. Okay, so let's look at an example. If we have a solvent and we have a solute, we can make a solution. So here I have 0.5 grams of salt and I have 50 cm cubed of water. So what we're going to do is we're going to add the salt to the water to make a solution. So obviously that hasn't dissolved yet, so we're just going to stir that, and we are going to make a salt solution. So that is now a salt solution, 50 cm cubed of water and 0.5 grams of salt. Okay, so what concentration is that? So NaCl aqueous. We have 0.5 grams of NaCl and we have 50 cm cubed of water. So concentration is equal to moles per decimeters cubed. So we're going to need to work out how many moles we have. Well, first of all, we're going to need this equation. Mass is equal to Mr. Mole. Mole is then equal to mass over the MR, or the relative mass. Now, what is the MR? So the MR of NaCl is going to be equal to 23 plus 35.5, which is 58.5. The relative formula mass, 58.5. Okay, so we have 0.5 grams divided by the MR, which is 58.5. That is equal to 0.5 is going to be equal to 0.085 moles. We have 0.085 moles of NaCl. Our volume is equal to 50 centimeters cubed. The volume of water is 50 centimeters cubed. Now, that's in centimetres cubed. 1,000 centimetres cubed is equal to 1 decimetre cubed. So we need to convert that into decimetres cubed by dividing by 1,000. Because centimetres cubed are 1,000 times smaller than decimetres cubed, we are going to have 0.05 decimeters cubed. So the concentration of NaCl, square brackets is one way to represent concentration, that is going to be equal to moles divided by decimeters cubed, or volume. So we've got the moles was 0.0085 moles divided by the volume, which is 0.05 decimeters cubed. So that will work out at 0.15 moles, sorry, correct units, moles per decimeter cubed. So what does that number mean? That number means that if we have 1 whole decimeter cubed of solution, if that's 1 decimeter cubed, that will have 0.15 moles of salt dissolved in that volume of solution. Okay, because remember, this means per, moles per decimeter cubed. So it is literally how many particles you have in that volume. Okay, and we can see that this is almost all dissolved. So the solution is 0.15 moles of salt. Okay, and that's pretty much all dissolved now. What 0.15 moles of salt in 1 decimeter cubed. Obviously this is only 50 centimeters cubed, so this will be 0.085 moles, but that is the concentration of the solution. Okay, let's work through some of the questions up here. Okay, so first question, calculate the mass in grams of calcium hydroxide present in 0.8 decimeters cubed of a solution of concentration 0.0857 moles per decimeter cubed. Okay, so what do we know? We know that the concentration of calcium hydroxide, CaOH2, is equal to 0.0857 moles per decimeters cubed, and we know that the volume is equal to 0.8 decimeters cubed. Okay, and we want to know the mass, but we can't work out the mass directly. We have our moles per decimeter cubed, so first of all we need to work out the moles, the amount of calcium hydroxide present. So what is our formula? Concentration is equal to moles per decimeters cubed. Okay, rearrange this. Moles is equal to concentration times decimeters or volume, decimeters cubed or volume. So that is going to be equal to 0.0857 multiplied by 0.8. So this is moles per decimeter cubed multiplied by decimeters cubed. And hopefully you can see that if we multiply these two units together, decimeters cubed cancel, and we end up with a number of moles. So what do we have? 0.0857 times 0.8, and that is equal to 0.0686 moles to 3 significant figures. Okay, now we need to use mass is equal to Mr. Mole to work out the mass. The MR of CaOH2 is equal to 40 plus 2 lots of 16 plus 1. Okay, or 40 plus 2 lots of 17, which is 34, so 74. So MR of calcium hydroxide, 74. So the mass we have is going to be equal to the MR, which is 74, times 0.0686. Okay, which is multiplied by 74. Okay, and that's going to be 5.07. So there are 5.07 grams of calcium hydroxide dissolved in the 0.8. Okay, so 5.07, let's enter that into the right place. Okay, now question 2. Question 2, calculate the volume of water needed to dissolve 0.288 moles to form a 0.6 moles per decimeter cubed solution. So the concentration of nickel sulfate is equal to 0.6 moles per decimeter cubed. We have the amount, or the moles, of nickel sulfate. The number of particles we have is 0.288 moles, and we want to know the volume in decimeters cubed. Okay, so what do we need to do? First of all, concentration is equal to moles per decimeter cubed, and now this time we want to know that. So rearrange that equation. Concentration times decimeters cubed is equal to moles, or decimeters cubed, the volume is equal to moles divided by the concentration. So we have 0.288 moles divided by the concentration, which is 0.6 moles per decimeter cubed, and that's going to give us our volume in decimeters cubed. And the question asks us for how many decimeters cubed. Some questions ask for centimeters cubed. Right, so what is it? So 0.288 divided by 0.6 is equal to 0.48. So that is also 480 centimeters cubed. Okay, so let's put that number in. 0.48 decimeters cubed. Okay, next question. Question 3. Okay, calculate the volume of water needed to dissolve 2.85 grams to form a 0.025 moles per decimeter cubed solution of magnesium chloride. Okay, so the concentration that we want of magnesium chloride is equal to 0.025 moles per decimeter cubed, and we have 2.85 grams of MgCl2. Now, we need to calculate the volume, but first we need to convert the moles. So we need the MR of MgCl2. The MR of MgCl2 is 24 plus 2 lots of 35.5, or 24 plus 71, which is going to be 95, and technically the units are grams per mole. Okay, right, so mass is equal to Mr. Mole, mole is equal to mass over the MR. So the mass we have is 2.85 divided by 95. So 2.85 divided by 95. 2.85 divided by 95 is going to be 0.03 moles. We have 0.03 moles, and now we can use the concentration is equal to moles divided by decimeters cubed, rearranging that to decimeters cubed is equal to moles divided by the concentration. So we've got 0.03 divided by 0.025. That is going to give us, it's going to be multiplied by 40, I think. So just pressing buttons, 0.03 divided by 0.025 is equal to 1.2. So we're going to need 1.2 decimeters cubed. And does the volume wanted in decimeters cubed? It does. Okay, excellent. So that is going to be 1.2 decimeters cubed. Okay, on to question 4. Calculate the moles required, or the moles present in 1.2 decimeters cubed of a solution of concentration 0.2 moles per decimeter cubed. So, ammonium hydrogen carbonate, NH4HCO3, the concentration of that is equal to 0.2 moles per decimeters cubed. And we have the volume is going to be equal to 0.12, and we want to know the moles. Okay, so what's the equation? Concentration is equal to moles per decimeters cubed. Rearrange this for moles is equal to concentration times decimeters cubed, or the volume. So we've got 0.2 moles per decimeter cubed. Sometimes this is given the big symbol big M, so it might be written 1.2 M in older questions. This is stands for molar. It's an older unit, but it means the same as moles per decimeter cubed. So 0.2 moles per decimeter cubed multiplied by 0.12 decimeters cubed. So the number of moles we have is going to be double it and divide by 10, 0.024 moles of ammonium hydrogen carbonate. Okay, so let's put that number in, 0.024 moles, and it's filled in the unit already. Okay, now the last one. We have ethanoic acid. Calculate the concentration when this many moles was dissolved in 5 dm cubed of water. Okay, so this is quite a straightforward one, so we'll just continue on this page. 5. Okay, what do we have? We want to know the concentration. And we know the volume is equal to 0.5 decimeters cubed, and we know the moles, the amount is equal to 0.278 moles. So what is concentration? Concentration is equal to moles per decimeters cubed. So we just put those numbers in, it's decimeters cubed, and we get 0.278 moles divided by 5 decimeters cubed. And the answer, 0.275 divided by 5 decimeters cubed is 0.055 moles per decimeter cubed. Okay, for the final answer. So let's put that in 0.055 and click submit and see what happens. Okay, excellent. So it looks like all of the numbers are pretty much spot on what the system is giving us. So hopefully that makes a little bit more sense of the concentration questions. Okay, so literally the equation is concentration is moles per decimeter cubed. You may need the mass equals Mr. Mole equation as well. Okay.